Hello students, this is JYOTSNA here. Welcome back. So in today's class, let us discuss about the next chapter that is called as the redox reaction. Well, as the word say redox, well, it doesn't have any relation with the ox, that is red, or a Red Bull. Well, it is just a word which is a mixture of oxidation and reduction. So OX comes from oxidation and RED, it comes from reduction. So the combination of reduction plus oxidation is called as the redox. So what does this redox mean over here? The reaction in which both oxidation and reduction takes place simultaneously are called as redox reaction. So what should happen? Reduction as well as oxidation should take place simultaneously. Means it should take place both at the same time. Such a type of a reaction is called as the redox reaction. Then why should we study about this redox reaction? Where is it finding its application? Well, the most important process, I think you must have heard about photosynthesis from the childhood. Photosynthesis is the process wherein the plants prepare their food in presence of sunlight. This is what we have studied. So during this process, what does the leaves do? They are going to use the carbon dioxide of the atmosphere and the water vapors which are present in presence of the sunlight. These leaves are converting them into its food. That is, it is converting carbon dioxide in presence of water and sunlight into carbohydrates and oxygen is released. This reaction is an redox reaction. So in this way, there are many such reactions which are taking place in our day-to-day life. Along with that one, you must have come across extraction of metals, which is called as metallurgy. So the extraction of metal also involves the redox reaction, wherein the metal oxide will be treated and we are going to extract the metal. So you can convert the metal oxide into metal by treating with and reducing agent like carbon. So whatever the metal oxide is there, it is going to give out the oxygen and in the form of carbon dioxide or any other form, and along with that metal is being obtained. So this metallurgical reaction also is an redox reaction. Along with that, certain redox titrations are also performed. So in this way, redox reactions are finding wide application. Hence, we have to study about the redox reaction. Fine. Then, let us look for what does this redox reaction actually means. Let us take one simple example. Suppose if I go to a shop to purchase certain things, let me say some pastry. So when I want to purchase, I'm going to give the currency to the shopkeeper. So there is loss of currency from my wallet. So this loss of currency, for example, is nothing but we can also call it in terms of chemistry, that is loss of electrons. So this is nothing but it is oxidation. When I'm losing the currency, the shopkeeper is gaining the currency. So the gain of electrons we can also say. So that is nothing but it is the reduction process. So loss of electrons is nothing but it is oxidation, and gain of electrons is nothing but it is the reduction process. So this is in terms of electrons. But there are different ways in which we can also talk about this oxidation and reduction. But In general, redox reaction is nothing but it is oxidation and reduction should take place simultaneously. So when I am giving the currency, there is loss of electrons or there is loss of currency. When I am losing the currency, somebody else is gaining the currency. So simultaneously there is loss and gain. So such a type of a reaction where there is loss in something and gain in something else. So this refers to as the redox reaction. Now, let us look for the various ways in which we can define the oxidation and reduction. Earlier, let us look for the classical idea of the redox reaction. Now coming to the classical idea of the redox reaction, first let us take a look of the oxidation. This oxidation is defined as addition of oxygen. Oxy means addition of oxygen. As you know that oxygen is an electronegative element, means it is present towards the right hand side of the periodic table. So not only just the addition of the oxygen, even addition of any electronegative element like addition of Cl or Br, any of these also is considered as what? Oxidation. So addition of the oxygen or any electronegative element to a substance, or when you are adding electronegative substance or an oxygen, equally if you are removing hydrogen or electropositive element from a substance, then also we call it as oxidation. So remember, oxidation means what? Either it can be addition of oxygen or electronegative element, or removal of hydrogen or an electropositive element from a substance. All this can be nothing but the oxidation. So if you remember about oxidation, reduction is exactly opposite to that. So what is reduction then? So it is defined as the removal. So here you have added oxygen or electronegative element, here you have to remove. So removal of the oxygen or an electronegative element from a substance, or here you have removed hydrogen or electropositive, here you are going to add the addition of hydrogen or electropositive element to a substance. So reduction means what? Removal of oxygen or electronegative element, or addition of hydrogen or an electropositive element to a substance. So remember, oxidation, exactly opposite will be the reduction. Fine. So this is the classical idea of the redox reactions, that is oxidation and the reduction. Then let us take a look of the redox reaction in terms of electron transfer. As I have already mentioned, so the oxidation means what? The half reaction that involves the loss of electron is called as an oxidation reaction. Remember, oxidation means what? It involves the loss of electron. As I told you, if I am going to purchase a pastry, I am going to give the currency. So there is loss of currency in my wallet. So this indicates what? Loss of electrons. What does it indicate? It indicates oxidation. Meanwhile, the reduction half means the half reaction where it involves the gain of electron, means the shopkeeper is gaining the currency. So here reduction means what? There is gain in the electrons. So that is nothing but we call it as the reduction. So remember about oxidation, exactly opposite is the reduction. Oxidation means what? Loss of electron. Reduction means what? Gain of electron. So in this way we are going to call it as what? As the reduction. Then coming to the redox reaction. So redox reaction during which loss of electron by one substance and gain of electron by the other substance take place simultaneously is called as a redox reaction. Means one is losing, the other one is taking it. So gaining it. So simultaneously this process is going to take place. So such a type of a process we call it as what? Redox reaction, where there is simultaneously loss and gain. One person is losing, the other person is gaining. So this reaction is taking place simultaneously. So this we call it as what? Redox reaction. Now after knowing the process of oxidation, reduction and redox, we also have something called as the reducing agent and the oxidizing agent. Now just take a look. Already we have spoken about oxidation where there is loss of electron, or let me say that I have given the currency. So there is loss of currency with me and there is gain of currency with the shopkeeper. So as I am losing the currency, I am supposed to be considered as reducing agent. So reducing agent means what? A substance that can readily lose electron to the other substance is called as a reducing agent or a reductant. The process is called as oxidation, but the one which is undergoing this oxidation is called as a reducing agent. Means I am giving the currency to the shopkeeper, so there is loss of electron. Process is oxidation, but I am losing the electron, so I am a reducing agent. So a substance that can readily lose electron to other substance is called as what? Reducing agent or reductant. Exactly opposite is what? Oxidizing agent. Now the shopkeeper has gained the currency, so he is called as an oxidizing agent. So a substance that can readily accept electron from other substance is called as an oxidizing agent or an oxidant. Process is reduction, but the agent or the substance which is undergoing this reduction is called as an oxidizing agent. So this is opposite to oxidation and reduction. Now let us take a look of the reaction and let us understand the concept. Let me take an example of sodium. Sodium combines with chlorine to form sodium chloride. Now during this reaction, what is going to happen? Sodium in its metallic state is having zero oxidation state. Chlorine in its elemental state has zero oxidation state. When it is forming a compound, that is NaCl, the oxidation state of Na will be +1 and the oxidation state of Cl will be -1. So from Na, that is zero oxidation state, the product formed is NaCl, in which Na is having +1 oxidation state, and from Cl, which is zero oxidation state, gets converted to Cl -1, that is -1 oxidation state. Now from zero oxidation state, it is converting to +1 oxidation state by loss of electron. One sodium atom is going to lose one electron to form Na+. Two such atoms are involved, so we are writing it as loss of 2 electrons. But per atom, if we consider, one Na is going to lose 1 electron. From zero oxidation state, if you are removing 1 electron, it is going to form what? Na+. So let us take an example over here. Suppose if I take Na, if you are removing 1 electron, it will form Na+ and an electron is removed. So Na is getting converted into Na+, means what? Loss of electron. This is the oxidation. So this is an oxidation process. Similarly, if at all I take Cl, if it is going to take this electron, gain of this electron, it will get converted into Cl-. So this is what? Gain of electron is what? Reduction process. So loss of electron is oxidation, gain of electron is reduction. These two processes are taking place together, so we call it as the redox reaction. So what is happening? We are going to take sodium. Here 2 atoms of sodium. We take Cl2 is leading to the formation of NaCl. So this is the overall reaction. In this overall reaction, we have half reaction this and the half reaction this. This is called as the oxidation half. This is called as the reduction half. Means half reaction is undergoing oxidation, half reaction is undergoing reduction. So therefore, we call it as oxidation reaction. This is the reduction reaction. Together, this reaction is nothing but it is the redox reaction. Now, during this process, we have also come across the other terms like the oxidizing agent and the reducing agent. Now, what is oxidizing agent or what is a reducing agent? So if the process is oxidation, the term which is undergoing this oxidation is a reducing agent. And if the process is reduction, the term which is undergoing this reduction is called as an oxidizing agent. Right? So now this sodium is undergoing oxidation to form Na+, that is loss of electron, process is oxidation, but this sodium is called as a reducing agent. And this Cl is gaining an electron, process is reduction, but it is called as what? Oxidizing agent. As sodium lose an electron, like for example, if I am giving the currency, I am losing the currency, so therefore I am supposed to be called as a reducing agent like the sodium, and the shopkeeper who is gaining the currency is called as the oxidizing agent. Together, this process is called as the redox reaction. In the same way, we have one more such reaction, that is metallurgical reaction. Now in this case, Fe2O3 is acting as an oxidizing agent, aluminum is acting as a reducing agent. Let us take a look of the process. Now, in this case, if you are going to consider, the oxidation state of Fe is +3 here and oxidation state of oxygen is -2. In this case, the oxidation state of iron is 0. In this case, oxidation state of aluminum is 0. In elemental condition, in elemental state, the oxidation state of the elements will be equal to 0. Now in this case, oxidation state of aluminum is +3 and this is -2. Now you can take a look. Fe2O3, that is iron in its +3 oxidation state, has got converted to iron in the 0 oxidation state. From +3 to 0, how it is converting? To this +3 if you add -3, means 3 electrons if you add, you are going to get the neutral Fe, right? So therefore, by addition of 3 electrons to 1 Fe, similarly 2 such Fe are there, means 2 into 3 is equal to 6 electrons total. So for one iron, if you are adding 3 electrons, you will get it as Fe. So Fe is in the 0 oxidation state. So gain of electron means what? It is reduction process. Now this aluminum, here it was in 0 oxidation state. It has got converted to +3 oxidation state. How? By loss of electron. So if at all you are removing 3 electrons from this, you will get +3 oxidation state. One aluminum, 3 electrons. One more aluminum, one more 3 electrons. Total 6 electrons. So this process is the oxidation process. Now we have also spoken what? If at all the process is reduction, the term which is undergoing reduction is an oxidizing agent. And if the process is oxidation, the term which is undergoing oxidation is called as a reducing agent. So aluminum is acting as a reducing agent. It is getting converted from 0 oxidation state to +3 oxidation state. And iron is getting converted from +3 oxidation to 0 oxidation state. Right? So this is a simultaneous process where reduction, oxidation takes place, and we call it as the redox reaction. So this is all about the introduction part of the redox reactions. Now, let us look for what is meant by electrochemical series and further explanation in the next video.